All right, let's do this. Today we're going to tackle the biggest story there is, the entire epic 4.5 billion year history of life on our planet. We're going from the very first chemical spark on a dead rock all the way through ice ages, asteroid impacts, and incredible explosions of creation, right up to, well, us. So buckle up, this is going to be a wild ride.
Everything really starts with this one simple but massive question. How in the world did a planet of just rock, water, and gas turn into the living, breathing, incredibly complex world we see today? That's the big mystery we're going to try and unravel.
So our story kicks off way back in the beginning, in a time of volcanoes and meteorites, a time before biology was even a thing. This first part is all about maybe the most incredible transformation you can imagine, that jump from just plain old chemistry to the very first flicker of life.
Now, the fancy scientific name for this is abiogenesis, and the most important word to focus on here is process. Forget the movie image of a lightning bolt hitting a puddle and bam, life. It wasn't like that at all. It was more like a slow, messy chemical assembly line happening over millions of years, gradually building more and more complex molecules until finally something tipped over the edge and could actually start copying itself.
Okay, so where did this all happen? For a long time, the classic idea was what Darwin called a warm little pond, or this idea of a planet-wide prebiotic soup. But lately, the thinking has really shifted to a much more dramatic place: deep-sea hydrothermal vents. I mean, think about it. These things are basically natural chemical factories at the bottom of the ocean, constantly pumping out energy and minerals. They're the perfect spot to kickstart life's first little engine.
So, how long did this take? This is what blows my mind. It happened incredibly fast. We've got evidence from these tiny, ancient zircon crystals that suggests some form of life might have already been around 4.1 billion years ago. That means almost as soon as the Earth cooled down enough to even have liquid water, life got going. It wasn't some 1 in a trillion fluke. It seems like it might be something that just happens when you have a wet, rocky planet.
All right, let's jump forward. Because once life got a foothold, it didn't just sit there. Oh no. It became a force of nature on a planetary scale. It completely re-engineered Earth in an event that was both one of the greatest acts of creation and one of the worst moments of destruction in history.
And you can thank these little guys for it. Or maybe blame them. Meet cyanobacteria. These tiny microbes pulled off one of the biggest hacks in history. They figured out a new way to do photosynthesis that used the one thing that was everywhere: water. It was an absolute game changer. But it had a side effect: a waste product that was highly toxic and reactive. That waste product was oxygen. And here's the kicker. For almost everything else alive at the time, which had evolved in a world without oxygen, this stuff wasn't the breath of life. It was a deadly poison. So as these little bacteria pumped out more and more of it, they were triggering the planet's first ever global pollution crisis. We call it the oxygen catastrophe.
And you can see the dominoes fall right here. First, the oxygen kills off a huge chunk of all life on Earth in our planet's first mass extinction. Then, it messes with the atmosphere's chemistry, reacting with methane and plunging the entire globe into a massive ice age. It's a total disaster. But, and this is so important, out of the rubble of that catastrophe, a new world is born. A world with high-energy fuel just waiting for a new kind of life to come along and use it.
And boy, did life take that opportunity and run with it. With all this oxygen floating around, basically high-octane rocket fuel for metabolism, the stage was set for life to get big and fast and weird and wonderful. This next chapter is just this incredible, unparalleled burst of pure evolutionary creativity.
It's called the Cambrian Explosion, and for good reason. After 3 billion years of mostly slime and single cells, it's like someone flipped a biological switch. Suddenly, in what is basically the blink of an eye in geologic time, almost every major animal body plan that exists today just appears. It's an absolutely mind-boggling moment in the history of life.
So what lit the fuse for this biological Big Bang? Well, it wasn't just one thing. It was like a perfect storm. You had more oxygen for fuel. You had the first true predators and prey, kicking off an evolutionary arms race for speed and armor. You had more minerals in the water to build shells and skeletons. And crucially, you had the evolution of a new genetic toolkit, these things called Hox genes that were basically the instruction manual for building complex bodies.
And right in the middle of all this action, our own ancestors, the vertebrates, are figuring things out, solving one problem after another. It's like a checklist of innovations. Okay, how do we eat bigger stuff? Let's invent jaws. How do we get out of the water? Let's turn these fins into limbs. How do we stay out of the water for good? Let's invent our own personal pond, the amniotic egg. Each step was a massive leap into a whole new way of living.
And if you're thinking, okay, that's a nice story, but where's the proof? Well, meet Tiktaalik. This fossil is just perfect. It is the absolute smoking gun for that transition from sea to land. It's got gills and scales and fins like a fish for sure, but it also has a flat head and these sturdy front fins that are halfway to becoming legs. It is the perfect link between two different worlds. But here's the thing about this story. For all its incredible progress, it's also a story of near total annihilation, over and over again. Evolution is not a smooth, straight line upwards. It's a chaotic history, punctuated by these massive catastrophes that just hit the reset button on the whole planet.
I want you to just let this number sink in for a second. Over 99% of every species that has ever lived on this planet is extinct. Gone. Forever. Extinction isn't some rare exception in the story of life. It's the overwhelming absolute rule.
At least 5 times, life on Earth was brought to its knees. We call them the Big 5 mass extinctions. They were caused by everything from ice ages to massive volcanic eruptions that choked the skies. The worst one of all, the end Permian, known as the Great Dying, wiped out something like 96% of all species in the ocean. It came terrifyingly close to hitting the off switch on life itself.
But here's the crazy, crucial twist. Devastation creates opportunity. By wiping the slate clean, these extinctions open up new possibilities for the survivors. And the most famous example, of course, is the asteroid that hit 66 million years ago. In one very bad day, it ended the 150 million year reign of the dinosaurs. And with the Titans gone, who inherited the Earth? The little guys who are hiding in the shadows. Our ancestors, the mammals.
And that brings us, finally, to the last chapter of this immense 4.5 billion year story. It's a chapter that's breathtakingly recent. It's our own.
So what set our branch of the mammal family tree apart? It really boils down to 3 big trends. First, we stood up. Walking on 2 legs, freed up our hands to make things, to carry things, to change the world. Second, our diets changed, letting us live in new places. And third, the big one, our brains just started to grow and grow and grow.
And this chart just lays it out so clearly. You can see this amazing feedback loop. Bigger brains lead to better, more sophisticated tools. Better tools let you get more high-energy food like meat, and that better food fuels, you guessed it, even bigger brains. It's this cycle that took us from simple stone flakes all the way to controlling fire, and eventually to art, culture, and everything we think of as human.
Our species, Homo sapiens, finally steps onto the scene in Africa about 300,000 years ago. From there, we spread out and covered the globe like no species before us. We met our cousins, like the Neanderthals, along the way. But in the end, for reasons scientists are still fiercely debating, we were the only ones left, the last humans.
So when you pull back and look at the whole 4 billion year picture, it is just staggering. Life has survived being frozen, being poisoned, and being hit by rocks from outer space. It's bounced back from moments that erased almost everything, and we are just the latest, incredible chapter in that long, resilient story. Which leaves us with one final, massive question. What comes next?